there, this is a re-recording of a session from September 30th, 2023, Introduction to C2 Infrastructure for Red Teams. Thank you everyone that showed up for that session and the one after for C2 redirectors. Before we begin, I'd like to give a good shout out to the Fox Hunt community, Tony Fontana. Thank you so much for all the support that we received. We also have to mention Dark Cat, who helped us come up with this logo and this design, and Mary's awesome. Contact her if you have any need on the graphic ends. She'll do a great job. First, I'll give a little about us intro. Then I'll describe the problem that C2s are a solution to. We'll touch on the components of a C2 deployment. We'll install and configure an open source C2 and establish a callback from a compromised machine as part of a demo. If you have a question, please add it in the comments. My name is Robert Pimentel. I work as a lead of offensive security at a Fortune 40 insurance company. I started Hacker Hermanos with my brother Rafael Pimentel, whose last name is now legally OSCP CRTO after passing these exams on the first try. Our Hacker Hermana and cloud developer Caitlin Farley, or Evil Pistachio. We've combined our powers and love for pen testing, cloud engineering, red team infrastructure, automation into Hacker Hermanos. So C2 frameworks are the modern solution to a problem that started quite a while ago. Originally, when compromising a system, we would get interactive access to a command interpreter through a network. Eventually, activity like this started being identified as anomalous and detected as a threat. Nowadays, seeing cmd.exe, PowerShell.exe, open a TCP connection outbound, it's an almost universal indicator of compromise. In 2003, one of the well-known command and control frameworks and suite of exploits was released, the Metasploit project. Ever since, C2 frameworks have been in constant evolution. Another notable release was the Cobalt Strike framework by Raphael Mutch in 2012, as well as Brute Retel in 2020 by Chetan Nayak from Dark Vortex. Modern C2 frameworks are still addressing the problem of sending commands to a target remotely. Why is this necessary, you may ask? Well, when compromising a system with an exploit abusing a vulnerability of some kind, we would want to obtain remote control to do our bidding. C2 frameworks help us establish a channel of communications between compromised assets and adversaries. The methods used for this channel of communication are just as important in order not to get caught. Modern frameworks help us blend in with daily activities and evade defenses. What is our bidding that you were just talking about? Picture this. That Linux server running the Apache application you just ran that exploit against return what we will refer to as a callback. That is, it connected back to our C2 server. If you have been playing in Hack the Box or Try Hack Me, they usually call this a reverse shell. From there on, you might be interested in downloading the files in the server, bringing in your own tools to identify opportunities to escalate privileges. Perhaps you're looking to extend your stay in the machine and move your callback to a different process. If on the other hand, you have obtained positive control of an associate's workstation, you might want to capture the keystrokes in hopes that they'll type in a credential secret, download the contents of their clipboard, or take in a screenshot of their display. C2 infrastructure relays commands and their results back and forth from our compromised targets to our C2 server. We know by now that C2 helps us connect to the target, send commands, receive results, etc. Infrastructure then enables those commands to reach the intended target and the results reach back the C2 server. There are several components to the C2 infrastructure that we'll touch on in just a moment, but for now, let's take a step back and look at the diagram on the right-hand side. We have three servers, and between the three, they're communicating to the targets over known network protocols. This is the part where C2 traffic blends in with normal functionality like web browsing and DNS. In this diagram, we use two common protocols for C2. HTTPS, which is encrypted web traffic, meaning that defenders cannot inspect the content of the connectivity without intercepting this encryption scheme and analyzing every packet. Plus, they'll need the keys. DNS is always DNS if you have worked in information security or IT for long enough. It is often not inspected in less mature organizations, and it is virtually everywhere, even in your smart TV. If we talk about the purpose of each of the channels, as you notice, there's more than one, what we're calling the short term, ST, we run most of our commands from it. It has a higher risk of being discovered and being blocked because it is connecting to our C2 server very frequently. Long haul or long term helps us ensure permanence on the target. We mostly use it to establish additional short haul or short term channels that will be used for riskier operations. As a result, the callbacks in the long term channel occur over a longer period of time. There's also the consideration of redirection. For this talk, we will not set up a redirector or talk about them much. This is something we do in Redirectors Edition. It's more of an intermediary level. We are going to delve deep into different methods of achieving C2 redirection. I'll give you a teaser for now. Redirection of C2 traffic can be done TCP forwarding, HTTP proxying, content distribution networks, and or a combination of these. When it comes to the components of the C2 infrastructure, at the core we have three. The C2 server, which is the backend server that interacts with the target. It controls how the traffic that is sent to and from the target is formatted. It generates implants that connect to the C2 listeners. It also modifies the characteristics of the traffic to blend in with normal network traffic like web browsing and common applications. Tony showed me a C2 server he was setting up a couple of weeks ago over Discord, which is pretty scary if you think about it. That C2 server would connect to its implant using your Discord application. C2 redirectors, I want you to think about these as traffic managers. They forward all traffic they receive back to our C2 server while only showing themselves to the target and potentially the defenders. They act as an intermediary and replaceable layer between targets and C2 server. The redirector allows the attacker to establish new channels of communication if they're discovered without having to create new C2 servers. And for this reason, all redirectors are replaceable. The agent is C2 implant is the piece of malware that once executed in the target system connects back to our redirector and in turn to our C2 server. You will still need to figure out a way to deliver this implant into the target system and have target executed. But for this talk, the initial access portion is out of scope and we'll just copy the payloads into the target machine file system in the upcoming demos. Let's briefly discuss some considerations related to operating this deployment securely and reducing liability. Let's also talk about the improvements that can be done when working with these deployments in a professional setting. Our C2 server is hidden by the redirector that sits in front of it talking about inbound traffic. This does not mean, however, that all the concerns are addressed and we might not have other issues. Additionally, depending on your intent, if you work professionally performing red team engagements like I do, you want to make sure that every precaution to prevent the infrastructure you're using from being compromised is taken. This could expose your employer or your customers to an incredible level of risk and be the end of your consultancy journey as well. In that case, I'd make sure that errors and omissions insurance policy is up to date. I'll just leave it at that. The concerns we want to address for OPSEC are, you want the blue team to have no indicator that this activity is being performed by the red team. Red teams are authorized to emulate or simulate threats. And with that, we take the realism aspect of our operations very seriously. We make sure to do everything in our control to look like real threat actors. But this does not mean that if we're emulating a criminal group known to use ransomware to coerce their victims into payment, we would run an uncontrolled malware that could potentially damage the customer. This is a critical difference between criminals and authorized offensive security professionals. We avoid causing impact to the business we're helping protect, audit, assess, because our goal is to improve the security posture. This is where guardrails come into play. These are mechanisms that we employ to ensure that our malware only executes in the system that we're authorized to target. They can be based on host name of the system, the network that the system belongs to, or the domain that they're joined as part of. Other operational security considerations include preventing malicious actors from compromising the red team infrastructure. For that, we use strict network controls, preventing anyone not authorized to manage our infrastructure to even have network level access to it. We often also use encryption keys that prevent anybody that could have a password and the username of the asset that we're controlling to even connect into it without this key. Deploying and configuring and securing all of these components on a frequent basis, it's a job on its own. These tasks are numerous, complex, and often repetitive. For this reason, I'm a big fan of automating everything that needs to be repeated consistently. Automation removes opportunities for human error, like forgetting to secure a server with the VPN or configuring a network security group to deny unauthorized access. Automation also allows the red team to start attacking the target network without having to spend too much effort on the deployment of the infrastructure required to do so. Some of the solutions we use to deploy resources of this kind include Terraform. When these resources are created, Ansible is a great solution to configure them. I personally specialize in writing complex deployments of red team infrastructure as code. I love this discipline and niche of our red team work, and I highly enjoy to deploy numerous servers and configure them with OPSEC considerations that we were just discussing already baked in just a couple of commands. So that's all we have for this session on the conceptual introduction to C2 infrastructure. If you have any questions, comments, please leave them down below and we'll make sure to reach out. Also, if you have a Discord, you can reach out through there. If you have a LinkedIn, please connect with us. I would be very glad to get to know you and hear about how we can share our knowledge on the things that we like to do. There are some resources that I use to put together this presentation. You can see them here. I recommend checking them out if you want to learn about these topics on a way deeper level. Also, I'm glad to start a discussion which you can initiate on the comments and hear your thoughts. If there's anything you think about that should be done differently, or I'm very glad to hear about that. Please support us on social media. We're very eager to connect with all of you. There's no point, in my opinion, on having a network if you're not reaching out to the folks and knowing who really you're connected with. So see you in the next one. Bye.